Hello, today we'll be talking about how to count atoms. And the reason why this is important is because we are getting into balancing chemical reactions. And in order to balance a chemical reaction, you need to know how much of each element you have and how many of each atom is going into the reaction. It should equal how much is coming out. This is based on the law of conservation of matter, which states that matter is neither created nor destroyed in a chemical reaction. It just rearranges and takes on a different form. So in order to really master balancing chemical reactions, you need to know how to count the atoms as they appear in the reactants and in the products. So in order to do that, we have to cover some vocabulary first. The first is coefficient. Coefficient is just like the coefficient you learned about in math. It is a number that is usually on the outside of a parentheses, and it distributes to everything inside the parentheses. Now, this is the same case with a chemical formula. If you see a coefficient or integer in front of a chemical formula, that integer will distribute to everything in the chemical formula, okay? So for example, here the number 3 is going to distribute to the calcium and to the bromine as a multiplicative property. So you're going to multiply 3 times the 1 calcium, so that gives us 3 calciums, and then the 3 times the bromines, which we already have 2, so 3 times 2 would be 6. Okay, so another word we have to cover is subscript. Okay, sub means under, script means written, so it is literally the number that is written under the element, okay? And it tells us the number of atoms of that element in that molecule. So it pertains to the element that it's sitting next to or under. So looking here, we're going to practice how to count how many atoms of each element we have in the compounds below. Okay, so here right away I notice that I have the coefficient 4, and this 4 is going to distribute to everything inside of the compound. So it's going to go to the sodium and to the bromine. So that means I'm going to have 4 sodiums and also 4 bromines. Okay, so keep in mind that there is an imaginary 1 as a subscript under each of these elements here, unless otherwise written. So you just have to do 4 times 1 and then 4 times 1 again for the bromine. For the next example, this is the molecule glucose, C6H12O6, and we have the coefficient of 5 in front. So this 5 is going to distribute to everything in the compound. It's going to be 5 times the carbons, 5 times the hydrogens, and 5 times the oxygens. So you're basically going to multiply. Okay, so for carbon, we have 5 times 6, so that's going to be 30 carbons. For hydrogens, we have 5 times 12, which is 60. So that's 60 hydrogens. And for the oxygens, we have 5 times 6 again, which is 30. So that's 30 oxygens. Now for the last example, something should stick out to you, and that is the parentheses outside of the phosphate. Okay, so before we do anything with the coefficient, we need to go ahead and distribute the subscript that is on the outside of the phosphate. Okay, so I'm going to multiply 2 times the oxygens and 2 times the phosphorus. Okay, so this 2 is going to distribute to everything inside the parentheses, okay? Then at the very end, I'm going to incorporate the coefficient. So it's just like in the rule of math, this would be considered PEMDAS. So you do everything that's inside the parentheses first. Okay, so right now I'm going to have 2 phosphorus and 8 oxygens, right? And this barium is not part of the parentheses, so we just have 3 bariums, okay? But now that I have the coefficient of 4, this 4 is going to distribute to everything that's in the molecule. So now we're going to do 4 times 3, which is 12 bariums, okay? We're going to do, well, let me stay consistent here. Okay, then we have 4 times 2, which is 8, so that's 8 phosphorus. And then we have 4 times 8, which is 32, so that's 32 oxygens. So now to finish off, I just want to leave with a quick exit ticket here. So let's say I have potassium carbonate, and let's say I have 4 molecules of potassium carbonate. So just like we mentioned earlier with the coefficient is going to distribute to every single element in the compound. So for potassiums, we have 4 times 2, which is 8. For carbon, we have 4 times 1, which is 4. And for oxygen, we have 4 times 3, which is 12. So that's how much of each we have. Okay, if you have a situation where you have the parentheses, when you have iron 3 sulfate here, keep in mind that this 3 on the outside of the parentheses is going to distribute to everything inside the parentheses, which is the oxygen and the sulfur. Okay, so my irons would be 2. This has nothing to do with the parentheses, so I have 2 irons. My sulfurs would be 3, and my oxygens would be 4 times 3, which is 12. Now, if I put a coefficient in front of that, let's say I put the coefficient, 2. Now, this 2 is going to distribute to everything that has been multiplied. So we're going to have 2 times 2, which is 4, 2 times 2, which is 3 times 2, which is 6, and 12 times 2, which is 24. Okay?